All right, so we're on 14.1. I'll go ahead and read the word problem there if you want to follow along. Pretty much one word problem for the whole lesson today. I guess before I start, I should talk about the title. The title is polynomial. Poly means many. However, that can be a little misleading. Let me tell you why. Let's talk about a monomial and then relate it to a polynomial. A monomial, you learned this in Algebra 1. A monomial is a number. So that's a monomial. A monomial is a variable. Or it could be the product of a number and a variable. So these are all monomials. This is a monomial. This is a monomial. When I put them together, now I have a polynomial. So here's why it's misleading. A polynomial is technically one or more monomials. I think it should be more than one, but I didn't make the rule. So technically a polynomial is one or more monomials. So here you have three monomials. So that's a polynomial. These are actually called trinomials because there's three. That's called a binomial. But then they run out of names. So binomial, trinomial. They don't have a name for 4 or 5, or I don't know them. So they just call them polynomials. Technically, one term could be a polynomial. So here's the problem for today on page 227. The United States Postal Service will not accept a rectangular package if the perimeter of one end of the package, so that would be perimeter like W, 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 since it's a square. They will not accept the rectangular package if the perimeter of one end of the package plus the length of the package is greater than 130. Consider a rectangular package with square ends as shown in the figure. Number 1, assume that the perimeter of one end of the package plus the length of the package equals the maximum. So it could be less, but we're going to assume you're going to go for the maximum, which is 130. Complete the table with some possible measurements for the length and the width of the package, then find the corresponding volume of each package. Let's do one or two together. So let's come up with a width. Let's say I want a width of 10. My table is already labeled, so I don't need to put 10 inches. If I want the width to be 10, that means I've got 10, 10, 10, and 10. So I've already got 40 inches accounted for. The most amount of inches I'm allowed is 130. So how much would be left for the length? You can just say it out loud when you know it. What's left? I've used 40 and I have 130. 90. Let's pick another number. We're doing the perimeter of the width and the length. And the cutoff is 130. So let's say I want a perimeter of 20 or a width of 20. I'm going to have 20, 40, 60, 80 used up. That's for the perimeter. The total allowed is 130. So how much is left? 50. Don't do the volume yet. Go ahead and come up with 2 or 3 more possible widths and a corresponding length. Allie Cole, can you give me another one that you have? What's the width?
5.
5. What length would go with that?
110.
Okay. Caitlin, do you have another one that's not up here?
No, but I can.
Okay. You give it to me when you get it.
What's 30 worth?
Let's see. 30 and 30 and 30 and 30. So that's 120. So your length would then be, yep, that works. Does anybody have another one that's not up here? Yep.
898.
8 and 98. Okay, so those are possible dimensions, a width and a length. Let's see what the volume of these boxes would be. How do we find volume? Is volume just width times length? That's not volume of a box. You guys have taken geometry. This is one of the easier figures to work with. The volume is how big the base is. So the area of the base times how many of those bases you have. So times the height, or in this case, length. So it's going to be the area of this, which is width, times width. You have to multiply it by how tall it is, which in this case they're calling L. Let's do the first one. You're going to have a 10 times 10 base times the length of 90. Didn't really need a calculator for that one. 9,000. And the next one, 20 times 20 times 50. 20,000. Complete your table or the table I have up here, either one. Raise your hand if you initially tried a number that was too large and didn't work. Anybody? Nobody tried 40 for a width? Let me show you what happens. If I say I would like the width to be 40, that's 40, 80, 120. That's 160 inches accounted for. That leaves nothing left for the length. So there is a limit to how high the width can go. See if you can come up with, this is sort of a question for later, but we'll talk about it now. Come up with, maybe we'll do it once we get to something else. Hold that thought. Number 2, give an estimate for the largest possible volume of an acceptable United States Postal Service rectangular package with square ends. Just give your estimate. What do you think is the highest volume that you could get? Our highest shows 20,000. Possibly we could get a little larger. Just put your guess. We'll find out your guess later. So write it down. We'll see if who gets the closest. If it's 20,000, that's no fun because then we might all have that. The next questions are on the next page. I'm going to leave my slide on this page so that I can kind of view what I have so far, but you can flip to the next page. Number 3. 3A, use the package described in item 1. Write an expression for length, L, of the package in terms of W, the width of this package with the square ends. What are we doing? Writing an expression for L in terms of W. We want to know, what is L? Did you find L a couple times? Did you do that from knowing the width? Yep. How did I find this length of 90? I took 10, I multiplied it by 4, then what did we do?
Subtracted it.
It's from 130, right? So then we did 130 minus that. How about this one? I took 20, I did that 4 times. I subtracted that number from 130. How would we get this one? We would take 5, multiply it by 4, subtract that from 130. Are you noticing a pattern for how to find L? Write down your pattern using a formula or equation. So to find length, to find this length, we did 130. Is it going to continue to be 130? Yep. Each time it was minus, is it going to be minus? Yeah. This number kept changing. What number was that? The width, you would multiply it by 4. When I first read it, not many came up with that. Maybe I didn't give you enough time. But when you're struggling with word problems, just look at an example. And if you don't have enough examples, come up with more. So say, how did I find the width? How did I find the width? How did I find the width? How can I generically find the width? Just explain it with variables. Does this make sense now? Okay, so that gets you 3A. B, write the volume of the package as a function of W, the width of the square ends of the package. Okay, so you should be a little better at this now. How am I going to write a function for V? How did you do it 4 times? How do you generically do it in a formula? So to find this volume, I did 10 times 10 times 90. This one I did 20 times 20 times 50. 5 times 5 times 110. There's a pattern there. To find the volume, I take the width times the width times the length. You could have written W times L if you want. Anybody see a small problem with leaving this as my answer for volume?
It's not in terms of.
Thank you. Yeah, it says to write it in terms of W. I can't have 2 different variables. I have to have just W. My only input can be W, so that W squared is fine, but that length can't be there. Obviously, we can't just get rid of it. It's not going to give me volume. What do I do with that L since I can't write it? Jesse?
You like replace it with the equation.
Very good. This is L. So that is what you could put there instead. Good job. Please go ahead and write this in standard form. Distribute it out and write the highest term first. Tyler, is that a quadratic function? No, it is not. If that negative 4w cubed wasn't there, yes. That's not a quadratic function. It has a higher power than 2. Is that a polynomial? Yeah. A polynomial is one or more monomials, and a monomial is a number, a variable, or the product of a number and a variable. So I have this monomial and this monomial, and when I add or subtract them together, it is still a polynomial. All right, we are going to graph it in just a second. Let's go back to the one I wanted to ask about earlier. In this table, we tried some widths. How do I figure out the maximum width without just guess and check? How do I figure out the maximum width without just guess and check? Yeah. Set equal to what? Kind of, yeah. Let's look at this that we wrote, which has the 130 in it. Can our length be 0? Isn't that like our cutoff? Like we can have a bunch of things. We can have a length of 10, 20, but we can't have a length of 0. So if I were to put a 0 in here, that would be like my cutoff point. And then I could solve this. So if I move the 4W over, divide by 4. Can you guys type in 130 divided by 4?
$32.5.
Thank you. This tells me what width I can go to. I can start at 0 and I can go up to 32.5. But once I get past 32.5, when I go to plug that in, it's going to give me a length of 0, and that's not allowed. Any bigger numbers are going to give me a negative. That's kind of how you can figure it out. All right. On your graph, you should have some graph paper there in number 5. Let's talk about how we're going to make our graph. So a lot of times we struggle with what we're going to count by. So let's do your x-axis first. Let's label it. It's not really x. Let's go back to our function. Wherever you wrote your function in vertex form, write down what a point would be. Dollars, people, inches, like what is x or your input and what is your output? We know it's W. What did W stand for? It stood for the width of the acceptable package. Your output is B. That's easy to remember. That was the volume that we get. So that's going to help us make our table. We know what's X and Y, width and volume. So please go to your table. Label this one width, parentheses in inches, the y-axis, axes, volume in inches cubed. Okay, so I was saying people have trouble figuring out what to count by. We just figured out for the width, we can go up to like 32.5. So I need to go to, well, let's not say 32.5. Let's just round to say we need to go to like 34, something like that. How many jumps are in your book? Are there 8 lines? Okay, so we have to travel 34 units. We have 8 jumps to get there. What's 34 divided by 8?
4.25.
Are we going to count by 4.25? Count by 5. Go ahead. That tells you what you want to count by. Count by somewhere close to 4.25, but make it easy on yourself. So let's go by 5. Let's talk about the y-axis. We're not doing negatives. We know it's going to go to 20,000, perhaps higher than 20,000. It might go to, did anybody guess over 30,000? Anybody guess over 25,000? Did you say 25,000?
I mean 30,000.
Okay, so let's say we want to go to 30,000. How many jumps or spaces are there? Is there 11? Okay. Okay, so 30,000 divided by 11 spaces is a not fun number. So what do you guys want to count by? This is what we should count by, but we're not going to. So 3,000 sounds good to me. You don't have to do that number because maybe you're not going up to 3,000, but this gives you an about. 3,000 sounds good. All right, I will allow the calculator to do the rest of the work. So you're going to grab your graphing calculator and you're going to put this function into it. Now you can't type W, which is fine, just X is good. So negative 4x cubed. Use the caret button, which is above the divide. Negative 4. The X is still up by alpha. The caret is above divide, so to the third. Notice you're going to stay up in the exponent unless you click over. Okay, everything you type after that is going to be up top. So hit over. I forget my function now. What was it? Plus 130 W squared? Thanks. Now my window is set to the normal negative 10 to 10. So my graph looks pretty terrible. Students struggle with the window. Well, we have a window because we have our graph. So our graph was 0 to 35. Let's just do that. I'm actually going to leave my window negative 10 because I don't like my cutoff being too close to my graph. If my cutoff is 0, I don't put 0. I go a little bit past it on the other end. So I'm going to do negative 10 to 35. For the y, again, we're not going to have negative, but I don't want my cutoff at 0. I'd like to see a little bit past that. So I'm going to go with negative 10 to 30,000. Now hit graph. I see negatives. Just know those don't make sense with the problem. You're not going to have a negative width or a negative volume. We need to graph this part. So the best way I would say to do that is go to table. Second table. And pick about 5 points or so. Don't pick them super close. Since your graph is counting by fives, maybe go to 5. And put that point.
My points are really weird.
Okay, let me see your graph. Or your window. Not window. White.
It's like the graph look the same, but my.
Oh, because you're in the 50s. You gotta go up a lot. 2750. I'm just going to graph plots, numbers at 5, 10, 15, 20. I told the last class we were graphing roller coasters today. They're not parabolas. They have sort of a similar shape, but it goes up and down more than once. So kind of like a roller coaster. Anybody need help with the graph in your calculator on your book? We're going to do domain range, which is number 4, and the maximum, which is number 6 in your book. Domain range is number 4. The maximum is number 6. But we don't know the maximum yet, so let's find that. So in your graphing calculator, second, calculate at the top. Of course, we're going to do maximum. Really, anywhere to the left of that highest maximum point is fine. Hit enter. Arrow over to the right side. Hit enter. Then don't hit anything when it says yes. Just enter again. And write that point down in your book. Think about what you should round to based on what the units are. If it's people, it's got to be a whole person. If it's dollars, hundredths. This one is width in inches. So there's some give or take there. Maybe the nearest tenth for width would be good. Volume, maybe the nearest whole number. That's your maximum. This is width in inches. This is volume in inches cubed. Yeah.
Can we really put 21.7 if that's not an actual point?
Yeah.
Like,
It is in, because you mean I didn't plot that point?
we know it's not a point on the graph because it was 21.666, so that's above that number.
Oh, I see what you're saying. I would probably allow it, but I see what you're saying. Yeah. It might be nice to know that it's rounded, but that's about accurate. Oh yeah, if we were to write this in context of the problem, like you were on your last test, there's something that a lot of you are forgetting. You were saying we can have a width of 21.7 inches, and that produces a volume of 20,342 inches cubed. But what's the significance of that? They all produce a width and a volume. Why did we pick this point? Yes, we picked a very important point. So you don't need just a generic sentence like width, volume, width, volume, width, volume. You say at a width of 21.7 inches, we reach our maximum volume allowed at 20,342. Let's write that, and don't forget the word maximum or highest or something to that effect. I suppose like Jonathan was saying, since we rounded up, maybe you want to do 27.6 so that we don't go over what's allowed. 21.6. Might be a better idea to round down. You can write that wherever, but it's asking you in number 26 and 7, what is it? And what's the significance in 7? And then our last question is number 4. I think it just says domain, but we're definitely doing domain and range. So domain, it stands for, in this case, the width in inches. It's nice to put a word. What is it? What is X? It's width. What's it labeled in? Inches. And then write the numbers. So our lowest width is 0. Can I have a 0? Can I include 0 for a width? No box exists with a 0 width. So we put 0, but we don't include it. And the highest was, I think we figured that out over here. 32.5 was the number, that sort of cutoff number that we can go up to. Can we include 32.5? Well, exactly 32.5 is going to give us 0. Can we have a length of 0? No. So it's actually not included, but anything up until that is included. Go ahead and write your volume. Words, label, and numbers. You can't have a volume of 0. That's not a box. You can include that maximum because it actually does reach that. It reached it at your width of about 21.6 or 21.5. All right, I'm going to put the homework up, and then I'm going to pass back your tests so we can go over the answers to those. Thought I had it written down.